Rick said, I'm Pete Bealo. I'm a member of the ATMs of Boston since about 1980, I guess. Been coming here since I was 16 years old. Actually lied once to get in. Back in the old days, you had to have, they sent out the announcements of Stellafane on a postcard. And if you didn't return that postcard the day you got it, you didn't get a camping place. And I was in college and went to my home and I was in school, didn't get it. By the time I sent it in, I couldn't get a place here. It was all booked up. So I found somebody to call up here and said, I'm a stupid college kid. I'm hitchhiking up to Stellafane. Where's the nearest campground I could find? And whoever it was said, you're hitchhiking from New York State to Vermont? I'm like, yeah. He goes, we'll make room for you. So I drove up to the plaza down at the bottom of the hill, parked the car, thumbed up the hill with my tent, okay, set up tent, found somebody I knew, drove me down, I got in my car and came up here. And that kind of problem's gone away now. We got, I would say, could handle probably another 500 people easily in from my visual look. So anyhow, I'm here to talk to you about AAVSO. Usually Mario Mata comes and talks about AAVSO. He's a longtime member. He's done a lot of observation. I've only been a member of AAVSO for 3.5, 4 years now, but because of retirement and COVID, I've spent a lot more time doing it, being involved in it over these last 4 years than I might otherwise have. I'm not talking about us as in general. I'm talking about initially the equipment or instrumentation and equipment section. So AAVSO is composed of a number of departments, if you will. Think of it as a corporation. There's a section for people who are interested in rotating binary stars, eclipsing variables. There's one for cataclysmic variables. There's young stellar objects. And there's this group of instrumentation and equipment section. And Richard Berry used to be the section lead of that. He has unfortunately had to step down. I know people know Richard Berry as an author. He's done a number of amateur telescope making books. He actually did Telescope Making Magazine. Sorry, thank you, Rick. 2 years ago, his house and observatory burned up from a forest fire, and he's trying to rebuild his life in Oregon, and he had to step down, and they were dumb enough to say, yeah, you can do it, you can handle it, to me. So, anyhow, first, what's AAVSO? It's an organization that's been around for 110 years, dedicated to observing and studying variable stars. Collaborate with the professionals, and we encourage and help enable amateur involvement. It's about 1,300 members worldwide, and the group supports members with a lot of things. There's courses on how to actually do variable star observations and record data and analyze data and such. We maintain a 110-year-old database of observations. So anybody, member or not, can go to the website, and if you're interested in a particular star, you can see all the data that's, the magnitude data available for that star over the last 110 years. And there's no other organization, to my knowledge, keeps that length of data. Maybe the BAA, but that's it. But we support observers with a network of remotely accessible telescopes, and I'll be talking about that later as well. And there's a number of forums for people to exchange ideas, ask questions, whatever. And the forum use does not require membership. So somebody who's just kind of interested but doesn't want to, put your toe in maybe first, can go to the forums, ask your questions, see what people are talking about, whatever. Maybe interest you. Oops, I shouldn't have done that. So initially we're talking about the instrumentation and equipment section, and that is basically a few people who are interested in developing new tools, new types of telescopes, new types of detectors, new types of filters, working with new types of filters, whatever, to enable better measurements or measurements of various variable stars and other objects. And when I think of people who design and make instruments and all that, that's us, guys. That's what Stellafane's about. So I thought no better place to talk to makers than here. So right now we've got members who are involved in evaluating the design and designing items to make observing easier. Supports all the observing sections and just amateur astronomy in general. And we have an online forum to compare notes and to ask for help or give ideas, whatever. Presently, there's just a few projects underway. One of the big ones is a flat field illumination system. If you do CCD imaging or even DSLR imaging, you're probably familiar, you got to do flats. So Alan Slisky and one of his sons are coming up with a flat field system that basically attaches to your telescope and is controlled by the same computer that's controlling your camera to automatically flip down some illumination and let you do your flat fields and then flip out of the way. So that work is underway. There's a water sensor under development. It's actually, the sensor itself exists out in the world, but they're putting together a PC board that's compatible with Alpaca. I guess that's the new version of ASCOM in order to communicate with your system and all. Because it's good to know when it starts raining, when the dome's open. And then the other thing which is underway is filter characterization. A lot of variable star observing is done through some specific filters. And historically, these are colored glass filters. And sadly, some of the glass is no longer available. And even if it were available, it's problematic because some of the glasses absorb water and turn into frosted glass. So now there's some efforts underway to make thin film filters. And definitely can use some help in characterizing these. Or designing, if there's any thin film design people out there. This is just a schematic of the flat fielder. This runs off an Arduino. This is a look at some of the colored filter work. So there's one manufacturer just came out with a new set of filters, and like these curves are the kind of ideal curves, the historic curves for filters used, and they're telling us that these are the real filters they're making with thin films. You see the kind of different shapes a little bit. And we've had one member actually get a set of those filters and independently verify that yes, they really do look like the way they're being marketed, which is good. And now he's underway, he's trying to characterize if they'll work sufficiently. Okay, so I'm talking to you folks, as a longtime Stellafaner, and I know you folks do equipment. George East out there has designed and made a lot of equipment in his time, optical and mechanical, and as have a number of the rest of you. So we're looking for people to come share your ideas, contribute to ongoing design efforts, propose and participate in new design efforts, ask questions on any aspect of instrumentation design and use and all, and just help us. We're here we have some experts involved, to help you and see if there's any way to go forward with synergy. Again, our online forum at the AAVSO.org is available to non-members. You don't have to, decide to, become a paying member and all that. You can just, dip your toe in the water and see if there's something of interest for you and see if we can help you. And hopefully, ultimately, you'll be induced to join AAVSO, but it's not a requirement. Okay? So that's my first and short presentation. The second thing I want to talk to us all, this is a look at the beginning of our forum. We have a number of good people involved. Arnie Hendon, Gary Walker, George Silvas does software. Gary Walker, I would say, is primarily hardware and probably hardware design and electronic design. He's a longtime a member up here. Arnie Hendon's PhD astronomy, done photometry for a long time. I'm up there just trying to herd the cats. I'm not an expert in anything. Okay, I'm camping just above here in Sue's Field. I have a big dining fly up with some red LED lights around it on at night. Feel free to come by, stop, get some swag. I have some swag out over in the back from AAVSO headquarters. You know what I mean by swag, right? Okay. pick some up, or reach out to me, pbealo@comcast.net, if you have some questions or comments or want to discuss anything. All right, now this is not telescope making. This is more on the observing side. And I'm here to talk also about AAVSONet. Or you too can take photometric images with telescopes up to 24 inches in diameter without spending a fortune, not even a small fortune. And I use this network. I'm a user, not like in management of it. And I want to acknowledge it. We have to make some acknowledgments. There's a couple foundations that actually donated, oh goodness now, I think 4 or 5 Takahashi Epsilon 180s, which are about $10,000 per tube assembly, to the organization, and a number of Paramount mounts. And the world's been quite kind to the organization. SBIG and QSI have donated cameras. And I also want to thank Arnie Hendens down at the bottom, who allowed me to kind of plunder his standard presentation. Hopefully he won't be embarrassed by this. So what's AAVSONet? It's a group of 10 remotely accessible telescopes in the northern and southern hemisphere. I guess I can't say worldwide. There's nothing in Asia, but there are instruments in New Hampshire, New Mexico, Texas, Arizona, Australia, Hawaii, and New Zealand. And they range from these Takahashi Epsilon 180s, which are 180 millimeter diameter f2.8 astrographs, to 24-inch Cassegrains. So there's scopes optimized for large fields of view, not terribly faint, and then others for very narrow fields of view, but they'll take you to 19th magnitude. And these are they're run by AAVSO volunteers for the benefit of AAVSO members. There's no cost in getting data from any of these instruments other than to be a member. So unlike, if you go to iTelescope or something, you're paying so much per hour of use. With us, it's what is it, $80 membership a year, and that's it. We also have, over the years, established an image, call it a pipeline, to produce calibrated images that are automatically sent to you. If you're observing BU Taurus, which is one of my stars I observe, every day that there's a new set of observations for me, I get an email in my in-basket that says, you've got data. And I go to the AAVSO website, go to my account, and there's my images. And they've already been calibrated with bias, dark field, and flats, so I don't have to deal with that, any of that. I just have to take it and do the photometry from those images. So it's a very nicely organized system. Cost, like I said, it's just membership. So for me personally, at this point in life, my back of the envelope calculation is I get data, I use about 80 hours per year of imaging time across 6 telescopes right now. So it's costing me about $1 per hour. If you go to some place like SLU over the Canary Islands or iTelescope, wherever they are, I didn't look up their location, you're spending $25 to over $100 an observing hour to rent those telescopes. So what's the difference? The difference is when you go to iTelescope or SLU, you could say, I want to spend 10 hours doing the Orion Nebula or the Gum Nebula, or you pick the object you want, okay? With AAVSONet, we're really limiting it to scientific observations for photometry of variable stars. There's a little bit of exoplanet work, but it's mainly variable stars. So if your interests meet that, we can get you almost free telescope time, is the bottom line. I mentioned there's 2 types of systems. We call them bright star and faint star monitors. The bright star monitors are mainly these Takahashi Epsilon 180s. And they got a nice big field of view, a degree by degree and a half field of view. And I take data down to about 15th magnitude from those. And then we have the faint star monitors, which are either 20 or 24-inch instruments, and with a variety of focal lengths. There's a 20-inch f5 Newtonian, and there's a 24-inch f15 Cassegrain. And that Cassegrain has next to no field of view, but it goes real faint. And I've done photometry down to about 19th magnitude in BVRNI. Again, fields of view are much smaller. The smallest is about 14 by 14 minutes. Although the others, most of them tend to be more like 30 by 30. Yeah, no one's expected to go through this. There won't be a quiz. But I just want to point out that we've got bright star systems, TOC 180s in Australia, Hawaii, New Mexico, New Hampshire. We have a AT-72 telescope. It's a refractor in Australia. We got a TeleVue 101 in Texas. All of these have good CMOS cameras. All of them have at least BVRNI filters. Some of them, the one in New Hampshire, is run by Arnie Hendon, who's basically a professional photometrist. He's got so many filters, I don't know what half of them are. So he's got the standard stuff plus available for use. Then we have the faint star monitors, Madronas Peak, Texas, Mount John University in New Zealand, Sonoita Research Observatory, which is going to New Mexico. I believe it was in Texas. It's moving right now, and Tortugas in New Mexico. This is just a picture of a Takahashi 180 on a Paramount in one of our observing sites. Each observing site has a local person basically making sure that the systems are running so that they all have good up times, and if something goes down, there is a local to get them back up and running. This is a 61 centimeter scope. OC61 is in New Zealand, I believe. And this is Madronas Peak in Texas. This is an Arcos Cassegrain. As I mentioned, you get images. This is a screenshot of the image, one of my images that came down to me. They're calibrated before they come down to me. All I end up doing is the photometry. The blue, red, and green circles on the images just says what are my comparison and check stars and target stars in that field of view. All I do is the stacking in photometry. So to use this thing, you become an AAVSO member, submit a simple proposal. It's one page. Within 2 or 3 days, somebody from the telescope allocation committee will get hold of you, probably with questions. There's always a little give and take. Then images are taken, sent to your account. An email sent to you, the data is available. You analyze the data, put the final data up on the AAVSO database, or keep it, just keep it private if you need to or wish to. There's no hands-on telescope work done by the users. There's a group of 3 folks who basically run the telescopes all remotely. So you don't even have to get up at midnight and see if it's clear. It either is or it isn't. And if it is, you get your images. This just shows the data, kind of the data flow. So once you have approved proposal, it either goes to bright star monitor scope or faint star monitor scope. When images are taken, they're automatically come down the AAVSO pipeline and are calibrated, and they're sent out to your what's called VFOT, our analysis software. It's sent out to your VFOT account for analysis, or you can use anonymous FTP and have them, basically available on your home computer. Then you analyze and report, and that's it. Very straightforward. So science projects can be of many sorts. There's what they call legacy targets. I think I mentioned AAVSO has been around for 110 years and has data on some stars for 110 years. Some of those, for whatever reason, aren't being observed terribly much anymore. So there's like an active search for people to re-observe these legacy stars on a regular basis, just to kind of, we've got older data, then we're missing some data, let's start filling in new data for these things. There's what they call campaigns to support researchers. If some researcher, somebody at the University of Leuven, has some telescope time on the Hubble Space Telescope to look at particular variables, they often want to know what's going on with that variable star right before the observations and right after. What state is it in? Is it at peak magnitude state? Is it faint? And they basically, through AAVSO, put a notice out looking for observers to observe for a period of time and to kind of dovetail with their Hubble images or Swift images or what have you, whatever satellite telescope they're using. So there's a lot of requests for help with it from them. There are some unusual types of common variables that are identified from time to time where people are looking for input from or of. There's some transient objects. There's new nova in the sky. Let's use the network to observe this nova. Exoplanets are occasionally observed, not terribly often, mainly because to observe most exoplanets, you need 4, 6, 8 hours of dedicated telescope time. And AAVSONet tries to use each telescope for 6, 8, 10 projects a night. So something has to be particularly unusual to dedicate a whole night to one object. And then, of course, what's your favorite project? So the things I'm personally involved with, okay, there's a variable in Hercules, V1117, Herc. It's called the UX Orionis variable, which in theory it's a star that's surrounded by a cloud of dust and gas. And clumps of dust and gas occasionally occult the star, and it becomes faint. I'll show you some data on this in a little bit, but it's been really, to me personally, really interesting. There's other, I also observe a couple other UX Orionis and T Tauri variables. There's a variable called NSV 6690, which is an active galactic nucleus. It seems to be, it's theorized as being a pair of black holes that are circling each other. And it's a variable source in the center of this galaxy. And a group of Chinese researchers published a paper about 5 months ago now, where their theory is based on the period of variability. They think these two black holes are going to collide within 300 days. So it's like, oh, this is cool, right? So I put a proposal in to observe it. And I'm observing, and like 6 other AAVSO members are also observing and reporting data on this variable. And once we started getting the data, I reached out to these Chinese who published, and they had never heard of us before. They didn't realize amateurs did real work. And now they're signing in and uploading our data periodically, which is kind of cool. It might be useful, hopefully, maybe not. What else are we doing? Oh, BU Taurus and the Pleiades. It's an eruptive irregular variable. Nice thing about that is it's a very bright star. So I'm using one of the Takahashi scopes to observe that star. Well, Takahashi's got a 60 by 90 minute field, and I'm looking at the Pleiades. A lot of stars in the Pleiades. Most of them are variables. So I've identified, how many? 21 other Pleiades in the field, that field of view, and I'm reporting on all 22 of them. When I went and looked, like 20 of them had no data reported on them, ever. So it's like, okay, so let's just start filling in the database. V0616, Vulpecula, which is an X-ray black hole binary, and I haven't really seen anything interesting on that, but I read a paper on it, and it interested me, and no one else was observing it, so we're doing it. Just as a quick glance, these are variables I'm reporting on. The left column are ones I actually propose to observe, and the rest of this chart are, I call serendipitous observations. They're in the field of view. No one else is observing them. I might as well report on them. The ones that are green have seen, no one has reported on them at all in at least the last 5 years. The ones that are white have had sporadic data collected and put into the database. So, we're doing some unique monitoring and some ununique monitoring. So this is my V1117, I should call it my V1117, Herc. So it's really interesting. As we look, there's periods where it drops in magnitude pretty quickly, okay, with large periods of time between each drop. And as we look across this graph, you don't have to go by the Julian dates and all. It's roughly a 400-day cycle. So roughly every 400 days, plus and minus about 10, it drops by 2 or 3 magnitudes, which is interesting. But then in late 2018, it started becoming a little bit more complex. And that's kind of when I kind of glommed onto this. I'll show you more recent data. So this is since early 2019. It's totally changed. And so we're seeing these first there was like this big drop for a few months in magnitude, and it went back up. Now there's an open area there. That's when it's behind the sun. We can't observe the thing. Okay? And then since then, we've get these like between every 5 days and every 20 days, it drops 2 to 3 magnitudes. And as you can see, like at brightest, it's around 12.5. But down here, we're getting down to 17 occasionally. And no one knows why. You know, why are there now these relatively small clumps occulting the star at relatively high frequency? You know, and hopefully if we collect enough data, we'll be able to help the theoreticians come up with some wild guesses on that. But I just find it fascinating. Every day when I see I have V1117 data in my inbox, it's like, ooh, I got to go check it. Where are we today? Is it dropped again? Because it'll drop a magnitude to magnitude and a half in a day, you know, between sets of observations. It's really, to me, quite bizarre. Now, as I'm observing 1117, there happens to be V118 in the same field of view, and I've been observing that. And that is a semi-periodic variable. It has a period of, the estimated period is like 400 to 500 days. And I'm just kind of taking, this is free data. You know, I'm observing the star in the same field, I might as well report both. And no one else has been reporting on this. And we're reporting in various wavelengths. This is infrared, red, green, and blue. Bum, 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 bum. Now, I mentioned variable star observing traditionally had been the work of visual observers. People just did visual comparisons in their field of view. People still do that. Okay, you know, not everybody needs a big, expensive CCD camera and set of filters. So this shows Z Taurus over the years, and there's all the plus signs are visual estimates. Okay, and basically over the years, people have been estimating that it's tends to go from around 11ish or so down to 14, and then back up 11ish down to 14. Well, somebody had the bright idea about like when it gets to 14, does it really stop there, or is that just where the visual observers just can't make any fainter observations? So they put two of a 20-inch and a 24-inch telescope on it as it goes faint, and lo and behold. So you got all the visual observers are seeing it like this. When it gets faint, it really goes faint. It went down to 17. And then a few cycles later, it went down to almost 18th magnitude. So we're kind of combining the technologies, the visual observer plus the large telescope observer. And it all plays together really well. I mentioned transient objects. There's nova, a couple dozen a year, supernova, maybe 100 a year that are observed. GRB, optical afterglows. I haven't personally seen these. Micro-lensing events. These are the kinds of things that AAVSONet can easily observe. Cataclysmic variables, a lot of people interested in those. Here's 2 years of SS Cygni. Off of AAVSONet. And again, a lot of people do this visually, and that's fine too, but these are all using the standard green filter, V filter. Novae, here's 10 years of V3339 Delphinus, which was a nova that occurred in, well, it's almost 10 years. It occurred in 2013. So we've been following that with this network of telescopes. Novas don't just occur in the Milky Way, right? So here's a couple images of a nova in M31, Andromeda Galaxy. And we could see it when it was bright, and we can't see it at its faintest, before it went nova. Here's 10 years of a supernova, or no, not 10 years. No, it's only, it's 180 days, so half a year of a supernova. SN 2011 FE in M101 observed from AAVSONet. So basically summary is, professional surveys are great, visual observing is great, but we have, a nice network of telescopes available to those of you who aren't equipped, to do these kind of observations, or who want to do observations, in hemispheres where you don't live. If you're really interested in something in the Magellanic Cloud and it's not visible in the Northern Hemisphere, we can help you on that. Writing the proposals are really simple. I've done 11, 10 of them have been accepted. The one that wasn't accepted just wasn't accepted because somebody else was already using a telescope on the network to follow that star. And I was told, if you're really interested in this star, reach out to so-and-so. He's already getting data, he can share it with you. But so there's not a necessity to have two different people taking fundamentally the same data sets from that network. If anybody's interested in this thing, you need somebody to mentor or just, kind of advise you, please reach out to me. If I can't help you, I'll find someone who can. I kind of made a career of not being an expert in anything, but knowing who the experts are and being able to find them and vector people to them. And I can help folks do that. And that's it. That's all I've got to say. Questions, comments? Yes.
Does AAVSO supply the photometric software for reducing the observations, or has it got to spend a lot of money?
Okay, so the question was, does AAVSO supply the software to do the photometric analysis, or do you have to spend the big bucks to buy Maxim DL or something like that? And the answer is, we have the software. It's online. It's really easy to use. Even I can use it. So yeah, you don't have to. Now, the other side of the coin is, if you happen to be an observer of whatever and you're using like Maxim DL, feel free to keep using it. It works just as well. So we're really software agnostic. We'll supply you the software for you to use or not, your choice. We also have data analysis software, things to do the mathematics, if you will, Fourier transform analysis in order to figure out what the periods of certain stars are or whatever. We have all that available, and it's all online. None of it ends up having to be stored in your system. Yes?
Linux, iOS, or Windows?
Well, the photometric analysis software is an app online, so we don't care. Okay? That's the long and short of it. And there are a few software packages that actually you have to download, and there are Linux versions of those available. There, I was going to throw you a pen, but you already have one. That was a good question. I owe you one. Yes. Uh-oh, Mario here.
I'll be kind.
Yeah, right.
I also followed a similar, very difficult style like V111 called WD1145 with the Harvard team. And what it ended up turning out, the paper that gave the clue to the team was a paper by Rappaport from MIT, where he theorized, as far back as I think it was the year 2000, he published a paper, that it's got to be a debris field to do stuff like that.
Sure, but like, why wasn't the debris field there before? That's the big question.
The thing is, we just got better equipment, I think. So in WD's case, it was a planetoid that came into the Roche limit. And it's probably that with V1111.
7, yeah.
Yeah, it's probably something like, because almost nothing else you can think of would do that. And it's probably recent because it didn't form a ring yet.
Yes, yeah, could be. And I'm doing, 3 of us are doing a paper on V1117. I'm working with Robin Ledbetter, who's a spectroscopist in the UK, does amateur spectroscopy, and Michael Paxson, also from the UK, who's more of a theoretician. So hopefully, my simple photometry plus some spectrometry plus a theoretician who kind of knows his stuff, maybe we'll come up with something reasonable. I'm hoping, Mario. And that was kind of you, actually. Yes? The question was, are there plans to support exoplanets a bit more? And I guess the answer is
Yes, Mr. Conklin.
right, but using AAVSONet telescopes to support exoplanets. That's the thing. I guess the answer is probably not. They just take up so much observing time. But as I mentioned when we had a chance to chat the other day, there are other avenues available, especially for educators. The Amateur Telescope Makers of Boston have a robotic observatory up called the Middleman and Astronomical Observatory. And most of these people haven't heard of this. And this instrument and observatory were donated to ATMOB, and it's fully automated, remote operated telescope. And part of the conditions of the donation were that we're to work with educational institutions that need some help. So you can potentially whistle us up to do some exoplanet work for you. So, anything else? Sorry. Yeah.
Does AAVSO monitor the sun, and does AAVSO have a radio astronomy section?
Okay, does the AAVSO monitor the sun and have radio astronomy? There is a solar observing section. I can't speak much to it because I see that the forum exists, but I don't go in and read what they're talking about. As far as I know, there's no radio. But that's a good, you get a pen too. Hey, I don't want to take stuff home. That's the bottom line. Thank you. Anything else? Yeah.
If we need an advisor and you are a volunteer, do we have your email or other contact information in the program?
You don't, but you do now.
Okay, thank you.
You're very welcome.
One of those two, please.
Sure, Rick.
Thank you.
I figured if I'm giving a talk, somebody's going to ask for it. I might as well have a few made up. And I'll do a shout out to my daughter who's back here. She's a software engineer and team leader for the company that owns Vistaprint. So I got a killer discount on these business cards. Like it wasn't worthwhile going to Staples. So, anything else? Okay, well, I hope you folks enjoyed the talk and we can be of service. Great. Again, I'm right up there on the hill.